Hello everyone, I'm going to talk about 188 best time to buy and sell stock 6 version 4 version. It's 4 whatever. You are given an integer array price where price I is the price of a given stock on the ith day and an integer k. For the maximum profit you can achieve, you may complete at most k transactions. For example, you may buy at most k times. Okay, this time and there's a different, it has another variables input now, and sell it at most k times. You may, this can be means like k transactions. Okay, note you may not engaged in multiple transactions simultaneous. You must sell the stock before you buy it again. Okay, equal to. So we actually, this one is don't need worry because if we don't have the stock, we cannot sell, right? So it will, which means invalid. By one, same example, but we have the variables equal to 2. By day 1 price equal to 2 and the sale on day 2 price 2, then the profit is 4 minus 2. Okay, so for this time is analyze first. So we got the same, right? So like 2 4 1 for this one, for example. We want to be the last day match the this is N1 2. So we want the last day max profit. So what we gonna do is to still use the it's kind of like a sub problem. So we have to, the last day depends on the previous day. So it's kind of like we start from the last day, but currently now we have some dependence, k now, and also we need to check hold. So we have to depend on 2 things now, -1 2 and k hold. It's kind of like a tree, look like this one, right? K1 not hold, and the tree will be bigger and bigger. So we have some conditions k, like n-2 is called like I should larger than 0, larger and equal than 0, but k you have to be larger than 0. This is different. So yeah, we can write this code like current node is on hold, and we translate the states into the hold. And on hold means like 0, hold means 1. So how could we get on hold, right? How could we get on hold is like we can use the DFS to do this problem. So I already mentioned the high level idea is use the DFS because we can separate this is a large problem and into the small one. So this is -1, translate like max previous, this one is 0 not hold, and make sure the k is valuable. DFS -1 previous one, right? This called I0 DFS like I -1. this means original hold, and this one is the price here. So maximum we have to pick up this one. Okay, so if we do nothing, there has this one. This is means didn't do anything for the previous 0. This should be 0. This should be 1. It's kind of like inherent. Inherent. This means inherent from your parents, right? Okay, so this is means like on hold. This is means buy. Buy means we have to pick up previous one, right? Whether current buy is maximum or I don't need to buy anything. It's already large, so you have to compare which is the max profit. And also we need to sell it. Sell it, we have to also same thing, maximum like DFS like I minus 1. You have to, this just means inherent, and also DFS I 1, and this is we sell it here, means 0. So this is kind of like a high-level idea about the overview about the status of translate. So we can use the DFS to translate this thing. This is the idea, high-level idea about these problems. So we have the entries, right? Entry DFS. We actually have the DFS I minus 1 K start from 0. We have to pick up the maximum one. DFS I minus 1 K1. Actually, this one, the last one, you have to sell the everything, which means the last one you should be 0. So if you have some stock, it will not be the maximum one. So we have to make sure K is this one. This one is always smaller, the profit is always smaller than this one. So we have to do that. Yeah, this is the high-level idea about this one. So we can write the code to better to understand this. So the high-level idea, the math tool is use the DFS to solve this problem. So this is the data transaction, and this is like a tree. We can treat like a DFS can always draw the tree to treat it like which row you have to go, right? Start from here and go. At the bottom, you have to return back. And then this one is the return the result. And this is the enter DFS. So we can do this thing. Same. Return the DFS like start from the last one. Okay. Let's hold. Hold should be 0. Prices int hold. Okay, so we have some case, right? If K 0, we actually cannot do, there's only twice, right? Twice transaction. If smaller than this, smaller than 0, K can be 0, but you have to, which means invalid. We cannot do anything now. Return the integer here. And also we have to check I if smaller than 0. We have two situations. Same if hold is equal to 1, which means invalid. At the beginning we didn't buy anything. And if hold current here means hold equal to 0, so we can return the 0 profit. At the beginning, profit is the 0. Now we can do something like a math. If the hold equal to 1, right? Previous one minus 1k prices hold. Previous we can choose inherent, and this one is not inherent. We have to, it's kind of our generation, we have to work hard. So this one is current is by myself, not buy from the parents. So this is should be paid for the price. And also I have to decide like when I selling it, treat is the transaction. So it will not do here. And I return the maximum. Also for here, if the hold is 0, we can inherit or just work hard by our generations. It's 1 and we can sell it. Now this one should be okay, -1. You can treat it, see it works fine. But this time complex might be very high. Yeah, so the time complexity, it will have this one, right? So it seems like a 4 branch. So we need to improve this one. So we can use the memory, same. But this time memory is kind of like we have to store this one, this one, this one. So 3 things we need to do. Like k, we have to +1 here. Because k cannot be 0. And for here is there are need 2 space. Okay, so okay, so for the int, one. Okay, we can translate to here and update here. It's memory. Okay, so this one is finished, so we come here, if member ik hold is not equal to -1, which means we already checked before, so we can directly return what we already checked the result. Ik hold this one. and this is the oops member. Maybe we can try this. Okay, it works fine. Yep. And the current now, the time complexity will improve to this memory actually. So it will be the n times k times 2. Yep. And yeah, this is the solution about this problem.